All right, let's look at the situation where we are trying to find a line of reflection. Now, sometimes we have this situation where we're trying to find a line of reflection where they just give us 2 points. There's no graph at all. And then other situations, we are trying to find a line of reflection where they do, in fact, give us a graph. So let's look at both. All right. So in this situation, I'm just drawing a rough sketch just to kind of give me a sense of what's going on. I've got point A at negative 7, 5, and it's going to undergo a reflection. So negative 7, positive 5. And it's going to end up at 0, 19. So 0, 19 might be kind of way up here. What line was it reflected over? Well, I can kind of imagine that it's going to be something like this. Now, how do I know that? Well, remember, when I connect an image and a pre-image, I know two things about its relationship to the line of reflection. First, I know that this is congruent to this. The line of reflection bisects this segment AA prime. The other thing I know is that it's perpendicular to it. It makes a 90-degree angle. I'm going to use those two facts to help me solve this problem. All right, so first things first. I want to know the slope of the blue line, and I know that it's perpendicular to the slope of the green line. Well, what's the slope of the green line? I can find that with my good old slope formula, like so, and I'm just plugging in the coordinates from my 2 points that I'm given. So I say, okay, the slope of the original green line is what? 5 minus 19, y's go on top, and negative 7 minus 0. X's go on the bottom, so this is negative 14 over negative 7, and the slope of the green line is 2. So if the slope of the green line is 2, to find the perpendicular slope, I take the opposite reciprocal. So like this is 2 over 1, so this slope is negative 1/2. So I know the slope of the blue line. If I only had a point that it went through, then I would be able to create a line using point slope. Well, I can do that, right? I can find that point. That point right there, let's call it M, is the midpoint between A and A prime. And I know how to find midpoints, right? The midpoint formula is I add the x's together, divide by 2. I add the y's together, divide by 2. And that's the midpoint. That's the midpoint. Let's do that. What are my x's? The x's are negative 7 and 0. Oops, not sure what happened there. Negative 7 plus 0 is just negative 7, but I'll show the 0 anyway. And then the y's are 5 and 19. 5 plus 19 divided by 2. And when I do the math, I get negative 3.5, and over here I get 24 divided by 2. I get 12. So now I've got a point. I've got a slope. I can use the point slope form of a line. So that is, again, y minus y1 equals m times x minus x1. What is my y1? That's from down here. It's 12. So I have the minus from the formula and the 12. I plug in my slope for m. X minus x1. What's x1? It's negative 3.5. So I write plus 3.5. That's the answer. Right? I can leave it like that. I could distribute and put it in slope intercept, but this is a good enough answer for what the problem is asking. This is the equation of this blue line of reflection.